I'm here on the Siemens booth, and today was the launch of the Grid Edge Revolution white paper. And I'm here with one of the authors, Joachim from TU Berlin. You were authored it in conjunction with the Oxford University, and with Michael from Siemens. The Grid Edge was one of the big talking points at this conference. And when I was chatting with Cedric, CEO of Smart Infrastructure, yesterday, I had said to him that the definition of grid edge, how do you define grid edge? And you have that in the white paper.
Yeah, so the grid edge actually is where the grid meets the consumption or production. And to make it descriptive, grid edge components would be, for example, the inverter of your PV unit.
Yeah.
Could be a battery storage, could be any electrical equipment that is connected to the grid.
Yeah.
But it's not only the hardware, you also have to look at the control technologies that are necessary for the integration. Because why does this topic pop up? Because we are now looking more and more at systemic optimization, not only optimization of grids isolated from those energy systems which connect to the grid. So we are talking about interconnectivity, about raising the overall system efficiency. And we are seeing,
The grid edge is a very traditional concept on the one hand side, but there are a lot of things going on both sides of the grid edge. So it's of course basically defined as the interface between the customer and the supply side. So everything that comes from the grid is delivered to the customer, and the grid edge is then the interface, and the customer just consumes. That's the old world.
Just the old traditional way.
And the many changes that you have already mentioned, technology changes on the hardware, on the software side, but also the flexibility requirements in the grid, in the whole supply system, make it very important and also very interesting to have a closer look at the grid edge, not only at one interface, but also for the processes that are going on both sides, and think about new business models, about new activities, about bi-directional energy flows that make the revolution at the grid edge very important for any way forward into the energy transition.
And I think the key thing there is, I spend my time looking at technology. So, look at the cool thing and you plug it in and it's great. But that's just an enabler. It's a piece of technology. It's the business models on top that solve some of the systemic change and stuff.
Let's go one step back. It's very important what Joachim mentioned. When I was trained as an engineer in the 80s in Germany and the United States, we had a different setup of the energy system. First of all, it was not such an integrated system as we are having now, and I think we'll talk about couplings and so on, decarbonization and so on later. And also, as you pointed out, the consumer was more or less passive. Maybe in those days even people would have called it a smart system, because it was a perfect match of what you need for a passive consumer. But now we have to reach to do this energy transition. We have to reach a sustainable infrastructure again. And that's why you see in many programs of countries globally, you see two top strategic directions. One is raising the efficiency, and the other one is raising the share of renewables in the energy system. These are the two core pillars of the global energy transition. And if you think that through, you will see that you will see more direct and indirect electrification. And you will see a higher and higher share of variable renewables, especially wind and photovoltaics. And this means we need more now overall optimization. We need more flexibility in the system, so that at times, you live in Berlin, when you have strong wind coming in from
the North Sea, whatever,
the environment of Berlin, then that the loads in Berlin sort of flexibly react and take that in.
And the very high share of that flexibility that is urgently required with a high share of renewable electricity production can and must come from the demand side. So to make consumers active and to combine them with their individual production devices, which can of course be large electricity production devices in the industrial sector, but also in the commercial, in the trading, in the household sector. We have a lot of decentralized electricity production technologies and also electricity storage. possibilities that must be not only connected but also steered via the grid edge in order to at least come closer to an overall optimum and ease the challenges that we have.
You mentioned earlier it's all about the energy transition, and to be honest, the energy transition is one of these words that's bandied around. In the paper, you called out 4 phases to get to the energy transition.
It starts with a very early stage where simply energy supply was the basic task, based on fossil fuels with the limits that we have to accept by today. So that's no further way. The next level is the power availability, the capacity to steer out the balance between electricity demand and electricity generation. That is a second step, also to be considered an element of the past. Now, what we just mentioned, the flexibility is the third phase, and that is becoming increasingly important. The more important the renewables become, and that's the solution for the climate protection goals. The fourth level will then be data. To have data available from the customer side, from the generator side, from the grid, in order to optimize the overall system. So therefore, it's several phases, and maybe that is the short version of the 4 steps in that.
And that came pretty fast, if you think about it. When I was trained in the 80s, it was just then that the digitalization started. We had digital control systems for drives, for example. We introduced digital protection relays, so it's not that long ago. And now it cannot work. It doesn't work without data, because the system complexity is increasing dramatically. But there's another aspect. We do not only need the digitalization like sensors, analytics, connectivity, and so on for running the system and optimizing the system. We also utilize analytics to faster innovate. And so topics are digital twins, for example, simulating, and these are topics where you can go around our booth here and you'll see. Basically, I spent the whole day here in this booth and have these discussions.
Your impression that so many things may be defined or considered as a part of the grid edge. You can start with sensors and actors, you can start with the hardware, you can continue and have to continue with the software, with the technology side and with the business model side. So it's a very wide aspect, which started as an idea of only having the interface between supply and consumption, and now it's becoming wider and wider. And important to mention that it's also integrating other sectors, other consumption sectors, and other energy supply sectors. So power to heat, power to chemicals, power to gas, and power to liquids are part of that as well on a large scale, and stepwise going further down to smaller and smaller customers and consumer segments.
Maybe to give some numbers, we said we want to reach a sustainable energy system, which means more renewable intake. It means more direct and indirect usage of electrical energy. Now, where are we globally? Typically, direct electricity usage is something like 20 to 25% of final energy consumption, if you look at the various countries. A majority of energy is used for heating, cooling. That's typically like 40-50% of a given energy system. In Germany, 30% of final energy consumption is space heating. And then transportation. We have like more than 30%, in some countries more than 50% of final energy consumption is for transportation. So in order to set up sustainable infrastructures and to decarbonize heating, cooling, and also transportation, we will see more and more couplings from the electricity sector into the heating, cooling sector, into the transportation sector. And you see, for example, back there, the charging infrastructure. It's not only the charging hardware, and you see here various types, but it's also the coordination.
Absolutely.
And that's where, again, the data comes in. You have to organize it. Otherwise, the system doesn't work anymore, because you will have, at time, have a tremendous power flow and overloading.
As a consequence of that, the grid edge is also something that is not static, it is moving.
That's true.
It is wide.
It's a dynamic system.
And the more and more we have prosumers instead of only consumers and producers, we may have in the next step with more intelligence on the consumption and production on the consumption side, even something that we in the paper called a prosumager, that integrates the management into that idea of having a more system-oriented optimization in the activities of the prosumers.
That's a new word for me. But one of the other things, and you've mentioned it already, one of the other things that caught my eye when I was looking at the report this morning, we hear everybody talking about the 3Ds. The decentralization, decarbonization, digitalization. You called out 5Ds. You had the decoupling and you had...
4 is the decoupling that has already been mentioned, with the other word for that, which is efficiency.
Yeah.
To have more economic growth and more people with fully satisfied energy needs without necessarily meaning more electricity or energy production. So maybe I should specify that it's not only about the energy needs, because nobody really needs or wants energy. It's always about the energy services.
It's what I use it for. I heat, transport, whatever.
Decouple these energy services from the energy consumption. That is a very important element in the future development, which makes me wonder why that is not always part of the 1, 2, 3, 4, 5 Ds in the general list.
I think the rest of the industry is catching on, but the other one you called out was the democratization, that I found fascinating.
Which is the outcome on the active side of the prosumers, where decision making can trickle down from large units and from large infrastructure further down and down to more and more individual companies or customers with own decision making ideas and possibilities to become active and participate in the market. And a side effect of that, but maybe not the least important, is that it also enhances the competition for electricity and energy supply, because so many people can participate. And the last element which comes with that is also more participation and hopefully more acceptance for the energy transition.
And when we were chatting earlier, one of the things around acceptance, which I thought was fascinating, was you look at what the EU is doing with energy communities legislation and when that goes through and whatever, and you look at the technology, and yes, you can have, I have solar on my roof and whatever, but you start getting into, but it's creating a social divide. The people with their money can get all this.
It is a big concern, not only in Germany, but I think in many countries that have really declared their objectives for an energy transition, that most of the technologies are extremely capital intensive, and therefore are open for investments from people who have the means to do that. And maybe a large number of people has to pay the bill nonetheless. So finding the right combination of progress, participation, and that is part of the democratization as well, and to find the right models.
The business model and stuff.
Business models to integrate also people who cannot go for large investments.
I think the social, if you call it social divide, or goes at least in two directions. One is the one that some are excluded from being able
they just can't
to actively participate. But I see also this other dimension of education, of information. So sometimes in my private life, I have the feeling that we engineers and scientists, we have good understanding what's going on and push forward, but we sort of lose the rest of the population.
You turn around and there's no one there.
And then you have at least two consequences. One is that the people do not apply the technologies that they could. For example, control technologies for optimizing the efficiency of the buildings.
Thermostats or whatever.
Thermostats or control systems for buildings and campuses. And the other one is, let's say, a pushback when it comes to new infrastructures, like transmission line built out, or going more towards renewables mean it becomes visible. You see the solar parks, you see the wind turbines, and they may blink at night and so on. Now, if you are convinced, yes, we need this is important, and yes, I'm part of it, then you have a total different approach compared to when you say, oh, this is only for those guys who want to fulfill their business.
Someone's got to make money and it's ruining the skyline.
So this inclusion is not only, it really goes in active participation and having benefits, and also understanding why it's going on. And And by the way, we need the swarm intelligence of the whole society to move forward. It's not only the engineers.
No, I agree.
The scientists.
If we're to get out of what we've created for ourselves and decarbonization in the future, then everybody, we have to bring everybody along, and everybody, you can't drag everyone along, they have to come willingly as well.
Yeah.
So.
And it's also about understanding people's wishes. This is very important to know and to understand when we set up new business models. So that's why, if I compare, like back when I started as an engineer, I would call it an engineer's world, and now really it's a world where we work interdisciplinary, and where we reach out also to the social sciences in order to really understand, does a technology fly or will it not be accepted? So in a way it's a more colorful world now and more fun.
No, agreed.
It's very interesting. It brings all the disciplines together and makes the new projects so interesting, and also to find new business model in order to deliver what the customers want. So it is also very interesting for utilities to go down that road and to invent, to create, and to bring not only technologies and their benefit, but also additional benefits to the customers.
No, and it's back to, how do you deliver value, and how do people perceive value from this, right?
What do people want? What does the young generation want, for example? How can you engage the young people? And there is a strong movement. You are right in the
very strong
hotspot. That's a movement in Berlin.
I'd like to integrate all age groups and take that as a picture for the grid edge, which is widening and integrating more and more, not only technologies and services, but also more people, more participants in the markets, in the new energy transition system, which in the end must lead to not only CO2-free, but a completely greenhouse gas emissions-free energy supply, not only on the energy side for private and household customers, but even supply the right stock materials for industrial processes.
Well, for hydrogen, ammonia, whatever, right? Sector coupling.
You see it, the other side of the booth is where we talk about the green hydrogen or hydrogen production. It's also about circular economy that we have to look at. So this is also again where digitalization comes in. So with digitalization we can only pre-calculate things or systems by setting up a digital twin and looking how it behaves, maybe coupling the digital twin to the real life and see how it behaves. It's also incorporating further aspects like later decommissioning, for example, already in the definition phase and the simulation phase of a new product. It's also these agile developments where you sort of try out at a very early stage and see whether it flies, and then continue with your innovation. So things are getting faster, actually.
Faster? Yeah. It's too fast. It's already slowed down. But no, it is fascinating. We could be here chatting for the next couple of hours because the paper is out today. It's well worth the read. My congratulations to the folks who wrote it. It's a meaty paper. There's a lot, and this whole grid edge topic is fascinating. No, hey, thank you very much.
Yeah, thank you.
Thank you.